Good afternoon and welcome to the Embedded Executive Podcast. My name is Rich Nass. I am with Embedded Computing Design. This week's guest is Ron Elliott, who is the Director of Field Application Engineering for Digi Infrastructure Management. How you doing, Ron?
I'm doing good. Thanks for having me.
My pleasure. So before we start and before we get into the topic that I really want to talk to you about, just explain very quickly, you're not, well, you are with Digi, but what does it mean, this infrastructure management?
Sure. So the infrastructure management, we focus on um, keeping their facilities up and running and being in line with if they've got a project where, like central compute, right? That's what we're all dealing with. Everybody wants to move to the cloud or VM or move to a data center. Our products allow legacy hardware that is not network based to communicate seamlessly, so they don't have to update applications. They don't have to rip and replace their infrastructure. That's where we come into play.
Okay, so that leads right into the topic du jour. A lot of these networks are old. I don't know if old is a technical term, but in our space, in embedded, something could be 15, 20, 25, 30 years, and that's not that unusual. So how do you stay up to date with the latest technologies when you might be running a network that's as old as it is?
Sure, it's a combination of things. For us, it's understanding currently people want to be network based, right? It allows you to just send data to a portal as we're seeing in the cloud, and they're wanting to do condition based maintenance, things of that nature. So in our case, we have to know both sides. We understand the legacy side, the serial communication that's out there, but it's also mission critical communication. And we facilitate that with our products and then a driver that we'll address as we get deeper into these questions. But the key thing is understanding our customer's business. My team, our primary goal is to go on site and make sure we understand the customer's current infrastructure, where their projects are going, and how critical it is and timeline to get there.
Do you ever get there and say, this just isn't going to work? This stuff's just not happening in today's world.
Of course, right? You can't solve all things. Like we can say, yes, our solution will provide serial communication over a network. But if you take me to a place and you're like, but there's no power here and there's no, cell connectivity, then yes, there's some things that we cannot solve. But more often than not, we're able to be creative enough because we've gone through it enough times. More often than not, we are able to find a solution for the customer.
But is the solution always something that has a wire?
No, no. So our devices are Connect EZ. When we get to the 2 port or higher, we can support what we call our core module, which supports cellular. That can have some concerns for people. I know back in the day they would use like a public static IP. Now, obviously, that's very dangerous. But with ours, we've got flexibility, right? We could do a private cellular network, which means that the devices are not visible to the outside world. We can do a solution where we use a VPN connection. So we secure that communication regardless. And so that's how we're able to make that transition. So if there isn't a wired connection in place, we can also use it. Some customers actually use it as a failover also. So if their primary line were to get cut, like right now, especially I'm in Minnesota, this is when we do construction season. We don't call it summer. And somebody with a backhoe tears up your fiber or tears up a copper line, and suddenly your communication is down. Well, with the cellular in place, you can always fail over to that.
Now you said private cellular. Is it really private? Is that something that is not hackable?
Um, if you do one solution called zero tunnel, which we won't dive too deep, but the termination point is really a head in with the customer, and then you place routers out in the field, and they talk back to that head end device. That's as secure as I can get from a private network standpoint. But most standards terminate at your data center and at redundant data centers on the cellular side, and it privatizes the IP addresses. So um, your standard hacker is not trying to get into a data center, whether it's at a cell provider or at your company. They want an easy target. So they're as good as you can get, is probably the best way to put it.
But also, isn't that an expensive solution?
No, most of the cell providers charge just a one-time cost, and the reason is um, them providing you with a public static IP, you get hacked. The hacker will then create an overage for the customer. Well, then the customer has to, they're going to fight it. Well, the cell providers don't want to have to deal with that. So if they can get you on a private network, it greatly reduces your footprint and your risk of being hacked and the risk of any overages that, are so astronomical that both sides end up having to waste time saying, okay, we'll credit you this, make these changes. So no, it's actually not very expensive in the long run.
Okay. And has the uh what's the word I'm looking for? The evolution of applications, like we're seeing a lot of robotics and automation and factory automation and things like that today. Has that changed how you guys do what you do? Or is it still just ones and zeros?
It's mostly ones and zeros. However, to the point of the robotics side and some of the more, um, or excuse me, some of the faster compute that we're seeing out there and what they call like a DCS environment, distributed systems communication, you are needing to have a processor that supports the faster protocols that are required. And they're industrial protocols. But for the most part, it is the same. It's just ensuring that your technology is keeping up with that communication level. So we have a mix, right? We've got some products that are really focused on older serial communication, which isn't very fast, but needs to be consistent. And then we've got some newer hardware that's coming into place that will support the need for the faster communication, sub-millisecond speeds.
Does it matter the size of the installment? If you have a multi-facility layout as opposed to just one factory, is it pretty much the same?
Great question. It is because we make our devices are made all the way down to a single port and all the way up to 32 ports. And so you're going to see our 16 and 32 ports are generally going to be in the, we'll call it main controller where they centralize their compute, right? And we're plugging in a multitude of devices. They're generally modems in place. And then out in the field, it may be one serial device, upwards of 8 serial devices. And so it's really just us understanding the project and what you need per site or facility.
Do you tend to use internal installations as, I won't say guinea pigs, but as your test sites?
Um, it's generally easier. So yeah, we'll normally start. So a lot of these customers have a almost a full-blown test environment that simulates their network on a smaller scale, obviously. And yeah, so we'll generally meet them at that facility, and that's where we'll start for the proof of concept or the pilot.
When things go wrong with a customer, is it generally that they screwed something up internally?
No, what we're
Of
seeing
course
is
not. They never do that, right?
well, it's one of those. It's a great question, but one of the things that generally happens is as your network changes and evolves, you can accidentally, right, create an impact that you just didn't know would happen until you actually made the change itself. So we'll generally start a conversation with, okay, what error are you receiving? What was the last change you made? But also in our hardware, they're able to provide us with what's called a support report that allows us to look back into our own device and go, okay, when did it start noticing a problem? And was it related to our device? Was it related to maybe even a firmware update, right? We have to try to take all things into account. What I usually tell people is start with, hey, I've got a paper cut. So start with the simplest, you know, potential issue, and then move to brain surgery. That came with experience. When I first started out, I wanted to go right to brain surgery, and they're like, actually, the cable's just unplugged, Ron. It's not that big of a deal.
That's funny. That's very good. Okay. So let's do the crystal ball test here. Say we're having this conversation 2 years from now. Is the answer just, oh, just throw some AI at it and it'll fix itself? Or what's the
uh,
solution?
I think that's what a lot of people would like. It's a combination, right? And it's one of the great things about our product. So we're generally agnostic. Plug your serial device in. I'm not worried if you're, where you got that device from. Um, that allows that data to go into an AI platform and assist with modeling that they're trying to build with all of the data they're receiving, not just from the hardware that they have connected to us. And I do see it improving like condition-based maintenance and the ability to be proactive and make some, optimizations on, at your plant and refinery. We are seeing some, initial compute at the edge. So running some light models at the edge and allowing for improvements right now. So I would say, I think we will have edge closer to being more proactive and doing more condition-based maintenance and optimization on our plants. But I don't see us allowing AI to fully run the plants in 2 years.
So you don't
It's a
think
wish, it's a dream,
you
but
don't
no.
think in 2 years you'll be a staff of one?
Oh goodness, no. What we're seeing AI provide to us is one, increased learning, right? If we want to learn something, I can learn it so much faster now because one, it can explain something to me, and then I am notorious for going down a rabbit hole, so I can keep asking questions and getting relevant information. But you have to be very careful. We use the word hallucinate when you talk about AI if it gives you an incorrect answer, but you're really just training it. So if it gives me an answer and I'm like, I really don't think that's correct, and I provide some backup information to support what I'm saying, it will go back and look. And that's where they're saying now, tell it to think harder, take your time, because it's so focused on speed right now. Just give me a quick answer. I think we need to make sure that we remind ourselves that it's not going to do our job. It's a great tool and a great assistant, though.
Very good. I couldn't agree more. Thank you very much, Ron. This is enlightening, and the the concept of don't start with the brain surgery, I think, is something people really need to take to heart.
Yeah, it's helpful. It saves time and it saves a lot of stress. If you start with the simplest thing, and also let the data guide you, right? We get a lot of information from our hardware. We get errors, we get log files, we get successes or improvements. We just need to make sure that we take a breath and ask some simple questions, look at that data, and then work accordingly.
Good stuff. That was Ron Elliott. He is the Director of Field Application Engineering for Digi Infrastructure Management, and I am Rich Nass with Embedded Computing Design.
Thank you.